All right. Well, hello, everybody. My name is Michael Rothenberg. I'm a territory sales rep for TV Pipe Solutions. Today, I'm with Kelly Schild and Chad Kitchens. And just for some heads up, I'll be distributing the questions as they come in. So feel free to use the question box along the right side in case anything comes to mind. And just as some quick background, TV Pipe Solutions is one of Contech's largest reseller of Contech products. And with that being said, I'll pass along to Chad and Kelly.
Okay. Kelly, do you have anything to add?
Nope. No, I'm good to go.
Okay. Sounds like everybody can hear me, so, or at least you guys can, so I'll assume this is working. So yeah, just a quick introduction of myself. And Mike, tell me, how many do we have on the call right now?
We have just about 15.
I'm sorry?
We're closing on that 15 number, which I think we should be expecting.
Okay, very good. So, so my name again, Chad Kitchen. I've been with Contech for about 13 years, working as a bridge consultant. And the topic that essentially we're going to be covering today is cost-effective bridge designs, especially when it comes to prefabricated bridge systems and maybe more non-traditional bridge types. So, as a whole, I don't know if you know, if folks are familiar with Contech, but Contech is a full site solution company. So we're not just bridges. We've been involved with pipes, culverts, underground detention systems, stormwater treatment systems, retaining walls, a variety of site solutions over the 100+ years that we've been around. So keep that in mind if you do have any other needs for a site development that we can help with. Anything that you see here in this screen is certainly something we could assist with. But again, we're going to talk a little bit more about bridges, and in particular with Contech, we divide it into 3 buckets, and these would be precast, plate, and truss. So I'll talk a little bit more about these as we go. One thing I should mention, I just realized this slide is a little bit old. On the right-hand side, it talks about U.S. Bridge being an old partnership that we used to have. Replace that now with Big R Bridge. Big R and Contech have now merged, and so this is an outdated slide, but just something to be aware of, that we have more capabilities now than we did before. So really, to kick off the bridge discussion, I wanted to show this chart, which divides the bridges, and more so than just what I mentioned that Contech provides. We really see that there's 3 different bridge types. On the left-hand side of the screen, you see culverts, buried bridge, and then bridge at grade. I want to talk a little bit about each of those as we go here. And you think, well, wait a second, a culvert, that's not really a bridge, is it? Well, we'll talk about what that really means and how it applies as a bridge in certain circumstances. But otherwise, everything you see highlighted in blue is something that Contech can assist with. It's essentially a Contech product, or something that we would engineer. The other more grayed out or browned boxes are something that is essentially an industry standard. As you move from the top down, these bridges become more expensive. So if you can start with a culvert style bridge or a buried bridge, those are going to be more cost effective than a standard bridge at grade, but they do have limitations on spans and available clearances. So keep that in mind. So let's talk a little bit more specifically about each of these different bridge types, starting with culvert. So again, we mentioned, okay, a culvert's not really a bridge, is it? Well, some DOTs do. I mean, they essentially anything over a 20-foot span bridge, they consider to be, a 20-foot span culvert, they consider to be a bridge. Now, this could be a series of culverts side by side, or it could be one large culvert, because we do make, round or pipe arch shaped culverts up beyond 20-foot spans. And so there is that ability to span either multiple barrels as a bridge, as long as it exceeds that 20-foot span range. So the reason why we look at culverts, obviously, is their cost. They're just the lowest cost option. Really, it's about passing water from point A to point B, usually under a road. We're not really concerned about stream disturbance or debris catching on these, especially if it's multiple barrel culvert, you can get debris caught on these. And so we're not concerned about those. It's more of a hydraulic design. And this is a project that essentially captures that. This is not moving water so much as it was a lake for a ski boats, and they're passing ski boats through this. But you see here, it's the nice part is that there's no footings involved, and they built their lake around it, and then you get their ski boats through there with the road going over the top. So just an idea of, okay, there's essentially a culvert that's acting as a bridge for boats essentially. And then contrast that with what we bump into the next series of bridge systems we call a buried bridge, and these can be either a metal or a precast concrete or cast in place. I suppose you could classify that either way. We get into these buried bridges, we're really looking more towards clear spanning something because we want to minimize stream impact and permitting requirements. And these typically are still more cost effective, both in terms of installation and maintenance in the long term versus a more traditional bridge. And we'll talk a little bit more about what the span ranges are for each of these, but they do have the benefits of the culvert and a combination of that with more of the traditional bridge as well. And here's a project where precast arch was essentially used in that capacity. This is a river going through here. They've obviously diverted, or they've working through this when it's low flow. I think they piped it around, and the end product was clear spanning that stream with a precast arch with precast head walls. They did added a bunch of feature to the head walls to give it a nice architectural appearance. So that looked real nice. And then they added some riprap on the edges to account for any scour. And then we move into the bridge at grade option. This really comes into effect when there's a long clear span required. Again, going back to the limited impact to the stream, especially where there's just not a lot of vertical element available. So when we need to, there's freeboard clearance required, we really need to look at something that's as low profile as possible, and that's when these traditional bridges are a better fit for those situations. This is a project, some may be familiar with this, southern Utah, Red Rock area, Moab, crossing the Colorado River. This was a pedestrian bridge that was put in across the river. This was a 618-foot span bridge, built in 3 different spans, fairly low profile. So that, again, that's something that you just can't do with a buried bridge. Much more economical to do it with a steel truss style bridge like this. So have we got any questions, Michael, so far?
Nothing yet.
Nothing? Okay. We'll go ahead and keep going here. So this is the Contech portfolio, essentially. And we mentioned here, culverts, buried bridges, and then your bridge at grade, and each of the different product types that are associated with that. We'll dive a little bit more into each of these here now as we go. But just keep in mind, hard to point to the screen necessarily, but there's span ranges available with each of these. If we talk about a buried bridge, we can span those up to 100 foot or a little over 100 feet with a precast. If it's a plate or a metal structural plate, we're upwards of 65 feet in span. And so those are definitely some economical options for those span ranges. And then as you move down, if you need something more in the 100 to 300 foot span ranges, we're getting more into these trusses and girders. So some of the things that we talk about when it comes to designing a bridge, I mentioned a few of these before. Cost obviously is a big factor. Clear spanning, freeboard and hydraulics, life cycle and maintenance costs are obviously a big part of it. Soil conditions can be a big thing. in terms of, building a footing or designing a footing to hold that bridge in place. And then, open bottom for fish passage and stream biology. These are all factors that we consider. And so if we're talking to any engineer that might be working on a project, these are the questions that we're going to ask and hopefully work through that process and identify what could be the most effective structure for that project. So here we jump into the specific, one of the first things that products that is on our list, which is structural plate. These come in both steel and aluminum materials, and there are reasons why we would use either one. These are the different shapes available in that structural plate. So anything from round to an arch, pipe arch, and then it does actually show on the bottom right, those steel truss bridges and those precast concrete arches are in there as well. But for the most part, this is a chart showing the different shapes available and size ranges for the structural plate. So just kind of quickly running through these. So, and then talking about precast, conspan, and bevo arch systems are part of the precast family for Contech. These are modular all the way from the footings, so we can do a precast footing, the arch systems, the head walls, wing walls. It all lends itself to rapid construction, and that's one thing that a lot of DOTs are all about, this accelerated bridge construction. So we bring these out on a truck, and within a day's time, essentially, a bridge can be set and ready for backfill.
Hey, Chad, one quick question.
Okay.
For large buried culverts, are there fish passage features that can be added?
What was the question again? Features?
For large buried culverts, are there fish passage features that can be added? I believe that's the entirety of the question.
Yeah, okay. So we've added like baffles, fish baffles in the bottoms of some of these culverts. That's something that we can do both for precast and for structural plate. So most of the time, when we work with biologists on that kind of thing, they want to keep that stream as natural as possible, and so we're usually clear spanning and not touching or doing much with the invert itself. But we can add some things to it if needed, and have done that before.
Okay, perfect.
So here again, the shapes, the variety of shapes available for the precast. And I would add to the shapes that each one has a range of spans associated with that. So, it's something that we work through that process when we know the parameters of the project that is being handled. So different things to discuss. When it comes to a buried bridge, it's really all about soil structure interaction. And the reason why we can get away with fairly thin material is because of the added stability of the backfill or that compacted material around that arch. So the arch will push some of that load into that backfill, and as long as there's resistance in that compacted material, we can put a pretty heavy load, either a live load or a dead load, on that structure. And that's the beauty of these arch structures, is that they handle a little bit more of that loading than maybe a flat top or a long beam span. We utilize a program called CANDY. It's Culvert Analysis and Design for designing and modeling these soil structure systems. This is a free download that you can see the link there at the bottom of that. So if anybody has an interest in looking at the program, for the most part, folks leave that up to us. Our engineers work through that modeling program, and we share that information as part of our submittal. But just to give you an idea of what happens as we model these things, this is a chart basically showing, or a model showing, the difference between a flat top, which is represented in the red, versus an arch system, which is shown in the blue. And you can see the moment here, the deflections going on between the red and the blue, and the significance. And really what it relates to is a thinner profile for the arch, all the way from the top slab thickness or the top of the arch down through the legs. You know, in this case, we're looking at about a 24-foot span box that you know, we can do something quite a bit thinner with an arch because of that arch top, and then analyzing through that Candy program. So just showing the efficiencies of this, going with this type of system, especially as you get to that 20 to 24-foot span range and higher. These arches really tend to be a more effective bridge or culvert. And then rounding out the bridge systems, we talk about truss bridges or steel bridges, both for pedestrian and vehicular. You know, we do a lot for pedestrian, but we're teamed up with Big R now. We're now part of the same company. So we've diversified quite a bit in doing much more in terms of custom designs and steel girder bridges as well. So I don't think I had much more about that. Just wanted to throw that out there.
Hey, Chad, one more question.
Go ahead.
And I'm just going to read it as is because I'm not too much of a bridge guy. But in mountain settings, the stream grade can approach 25%. Do the multi-plate need to be vertical? Can they be set at an angle that matches the stream grade?
Yeah, I think I understand. So there's a vertical element. I mean, probably the closest fit we have to something like that is we call it aluminum box culvert. Actually, we have that in a steel box culvert as well. So there's the ability to go vertical to a point, and then span with a bit of a flatter arch shape from that point over. And so hopefully that's answering the question. But you know, with that, we can span easily 30, 35 feet with those box culverts, the aluminum and steel box culverts. So I don't know if that answers the question, Michael, but
we'll see if he comes back with the second question, but appreciate you letting us know.
Okay. Are we opening up at the end for additional questions?
Yeah, I'll just open up to one final Q&A and then I'll wait from there.
Okay. So I think everybody's muted right now, right?
Correct. Yep.
All right. So if we don't answer questions, we'll have some time at the end that we'll open that up. So a few applications, bridge applications, I wanted to share just to show how these, you know, either buried bridges or culverts can be a fairly effective approach to a traditional bridge. You know, your traditional bridge, you got your roadway, your superstructure, your substructure, and you know, what we're suggesting is that, well, if you don't really need to span from top of bank to top of bank, let's look at a buried arch bridge where you're spanning over either a stream or maybe it's a trail, and removing essentially some of that substructure, and it eliminates a lot of maintenance. This is essentially acting as a culvert. It's just got fill material around it, and so the long-term life cycle costs are much less. There's just very little to no maintenance, not to mention the freeze thaw of a buried bridge versus the more conventional. So one project where this sort of put that type of scenario into play, this is the original design for a project in Mesquite, Nevada called the Exit 118 Interchange. And as you can see down there in the bottom, it was essentially about a 200-foot span bridge, traditional bridge. We came in with more of a buried bridge system and said, hey, would this be allowed? There was two separated bridge structures, big arches, that accommodated the traffic lanes and the shoulders and future widening, and still fit within the profile available. And so you can see here between the top and the bottom, the architectural features added, and eventually the city of Mesquite really liked that idea of pulling the architecture to the face of those bridges, and that's what they ended up with. These panel walls adjacent to the arch bridges. So this is a 78-foot span. I'm sorry, was it 78? Yeah, 78-foot span bridge. This is called the Bevo Arch Bridge. And 20, if I remember, it's about 28 foot tall to allow for that traffic to get through. So just an example, and in this case, the contractor at the end of the day, he told me that they did save about $250,000 versus the more conventional bridge. So definitely saved money and was I think more aesthetic at the end of the project. I think everybody was happy about that. So very large scale project in that case. Like I mentioned before, there are the advantages of converting to a buried bridge. Construction time is lower. That's something I haven't really mentioned. We didn't shut down traffic at all during that project. It was done through the night, and they bypassed vehicles on the off ramps to get around it. So they kept construction on the bridges through the night hours. Lower overall life cycle costs, shorter construction time. You can bury utilities in the backfill, and there's no freeze concerns and deck maintenance there. So those are some of the advantages of the buried bridge versus a bridge at grade. Now let's jump into a buried bridge versus a culvert example, and specifically a multi-barreled culvert. A lot of times, you see these box culverts thrown in. They're very economical and popular to use, but there can be issues when there's multiple barrels involved in terms of debris blockage. And the nice thing about an arch is that there's an ability to span. If you've got 3 10 by 10 boxes, well, we can span 30 feet with an arch and clear those center piers out of the way and open up that for improved flow, and maybe even decrease the span to an extent. And so here's a project in California. Everything's big in California. They have all the biggest natural disasters out there, right? So this project was a triple barrel box that wasn't working because of the extreme mud flow that came off of these hillsides, and just plugged that culvert, and it just didn't work. So Contech came in, worked with the engineer, at the time it was URS, and redesigned it with a clear span arch to replace those. I think they kept the same foundation, the same floor, and the same wing walls, and just inserted the arch and the head walls in place of those 3 boxes. So again, much improved hydraulics, no blockage area. Some of those events may get big enough that maybe this wasn't going to be do the trick, but certainly does improve the hydraulics with a single span bridge. Grade separation. These are some projects. This specific one is a project with Utah DOT, where there was an extension of an existing structural plate underneath I-15. And the nice thing is that they could do that. They could extend it. They just had to break out the old head walls. You can see on the picture on the left-hand side, there's some old plate, which is dirty, kind of that brown color, and extending out from a temporary head wall. And then the new plate structure was about 30 feet long, and it was essentially attached into or threaded into that old structure and then extended out to a new head wall. So this was to add climbing lanes for a mountain pass, and worked out really well. And actually, I should go back. That one had this is for a rancher and for wildlife to get through. So it was kind of a double application there. Another great separation. This project essentially was separating roadway going over the top versus one on the bottom. They didn't have a lot of vertical clearance. You see here, it's a very flat arch. This is an 84-foot span. The arch itself has about 11-foot rise, and then it's sitting on essentially a little bit of a pedestal or a concrete foundation there. But yeah, it gives them plenty of horizontal clearance for the roadway, the sidewalk, the stream, the park strips, and minimal vertical rise. And then more of a conventional bridge for grade separation. I wanted to point this out. This is more of a very customized bridge system called a tight arch, 315-foot span bridge. You see the arch over the top that holds the bridge. The truss bridge itself is really only meant to hold its own weight, and then you add the arch system to it with the cables to carry any live load. So again, in this case, 315-foot clear span bridge, no center piers. Okay, any questions?
Nothing right now.
Okay. So talk a little bit about relining. This does come up. You know, we've got aging infrastructure, and so there are occasions when we need to get in and not, you know, have as minimal disruption to replacing a road or a bridge as possible. And so we can use some of these same products to reline or rehabilitate an existing bridge. And so an example of this here, this is again a DOT project with Utah. They had to widen this roadway and replace the existing bridge. The contractor proposed an alternate, which was to take two side-by-side corrugated steel plate structures, pipe arches, and they assembled those underneath the existing. They backfilled them up to the bottom of the existing bridge before tearing it out. So, and while they were assembling these, there was essentially no disruption to traffic until they had, well, and even then they shoe flied around these. There was enough extra length on those plate structures that they shoe fly traffic around the existing bridge until they had demolished it and replaced it and buried it. So what you see here is that buried bridge now in effect. No deck maintenance, probably less concern about freeze and thaw, at least on the roadway over the top. And from a hydraulic perspective, it worked. It's all they needed there. So we're pretty dry here in Utah, so there's not a lot of water running through there. So that was an example of a structural plate being used to reline or rehabilitate. In this case, it's a precast arch bridge that was used to rehabilitate or reline a bridge. So here's the conventional old bridge. This is down in southern Utah, and they said, well, we need to replace that, and again, kind of do the same thing as widen that roadway. And so, you know, it's kind of hard to add on to that bridge. And they said, well, we're really just spanning over a stream and a trail. And let me see if I can get this. I don't know if this will work as well. So a video. Showing the process here. They pick these arches off a flatbed truck. They set them on this pedestal wall in the keyway on rollers, and then those rollers are used to help guide and push those structures into place. All right, we'll go ahead and stop. So there were, go back to that one. So you notice there's plates there on the side of the arch. Those plates were essentially there to jack the arch up. Once it was in its final resting position, it would be jacked up and those rollers would be pulled out and reused. So the rollers didn't stay in that keyway. They were, the jacks lifted the arches up, and then those rollers were pulled out. So again, you see here that entire structure was built underneath the existing bridge in its entirety, and then backfilled to a point where they could get traffic around it before they demolished the old bridge. And then this is essentially what they had. They stained the form liner finish and ended up with a really nice, call it a bridge or tunnel, whatever you want to call it, but that's that's the effect of what they got versus the bigger bridge that they would have spent probably a lot more money to replace. Okay, and then just one last thing I wanted to mention in terms of structural plate. You know, we have a product called tunnel liner plate, and in this case, this particular project was in Montana under, I think it was State Street in Billings, and they built a trail underneath the State Street or Main Street without excavating or open, I should say open cutting. They did excavate, but they just did it as a tunnel effect. And so these plates come in 18-inch segments, and so you build a ring 18 inches long or deep, and then essentially bore out the next 18 to 24 inches, and then add the next ring. And so it's all bolted together from the inside and on flanges, and it gave them the ability to build this 14-foot diameter tunnel underneath the road without open cutting. So that wraps up that. And then we'll talk here I think to end things on stream ecology. You know, we talked a little bit about that before. And so here's a project in Teton County. Old bridge was, you know, past its service life essentially. And so, and one of the things here was you know, getting fish passage through there. And so we came in with a precast arch system that was open bottom once again, and allowed for those fish to you know, to work their way through that much improved culvert or bridge. And then I mentioned, you know, the question came up about, you know, fish and can we add things. Here's an example of a precast arch that had these baffle walls essentially built in the floor, and allows for different flow variations for fish to rest or whatever they need to do inside of a culvert or a bridge like this. So so there is that ability to add these elements for fish passage. And that wraps up that part. Do we have any other questions that came in?
Yeah, we just had one that came in. Do the baffles come installed?
Do the what?
Do the baffles come installed?
Oh, yes, those do come installed as part of the floor. Yes, yes,
Okay.
They would come installed with it. All precast. So as far as you know, Contech. So Contech, you know, we have engineers that work on each of these different products throughout the country. So sometimes we're brought in as a partner. Sometimes you know, early in on the project. Sometimes it's later in. We get an order for a bridge and we just simply design it per a set of plans. So we're here to support in whatever level is needed. We don't want to take work away from, or billable hours away from engineers, but if it makes sense to look at these, they can be a very cost effective. I wouldn't call these essentially pre-engineered or pre-designed, but to some effect, or I guess I would say that they are, and they fit very well in certain applications. So they're very quick to engineer and produce and install. So anything we can help with from, you know, the development side to the design, through the design and then into the installation, that's what Contech is built for. There's some other things just to mention within that we do provide help with. We've done some photo site simulation. So you take a picture of an old bridge, and then we'll throw in one of our own in that site just to give some visual on what that might look like. So that's something our marketing folks are always happy to help with. And there's also a tool on our website called DYOB, Design Your Own Bridge. There's also DYOs for detention systems, and I think we're doing it for stormwater treatment systems as well. But design your own bridge for any of those product types, the plate, precast arches, and then those truss style bridges. You plug in, here's essentially an image of that that site and the information that is asking for. Once you plug all that information in, you'll get a set of plans sent back within probably 5 minutes, and you get your plan and profile views and a few details to go along with that. So conceptual drawings, you know, not a lot of detail necessarily, not enough to build it, but something to share. I've essentially worked off of these in a set of plans, and we've got it to work, but you know, usually it's more of a conceptual level set of drawings. Here's a structural plate with the same, essentially the same DYOB output. And then design support, you know, a lot of what we're doing is providing, well, we can do footing design or provide the reactions, especially with the truss bridges. We'll do more of just supplying the reactions, and a local engineer will design the abutments and the footings. So that's more common. But for precast arches, we're generally designing those footings in-house, but we're always happy to just provide the reactions and design support for those. And then in addition, you know, the contract drawings or submittal drawings, and that's part of the package that we would provide. Again, the footing design, foundation design with that. So that's pretty much the information I wanted to share in a nutshell. That covers all the bridge products and solutions that we offer. So I guess we can open the floor up for any other questions or anything that folks might want to talk about.
Yeah, and we can give them a minute or so to type that in. I do have one message that guys want me to relay. So if I was told that in 24 hours, you'll get the thank you for registering email along with a copy of the certificate. But if you need something more official to get your DH, just feel free to reach out and we'll get that taken care of for you. But looks like we just had one more question come in. Do you offer consulting if we aren't sure what we need?
Say again, what was that question?
Do you offer consulting if we aren't sure what we need?
Well, there are times when we will enter into an engineering service contract, you know, especially if it's maybe a design build project or just anything that you know, we want to get the design done before the full design submitted before you know, before the city reviews it or whatever. A lot of times, traditionally, we'll send bids in on a project that has a set of plans with just the basic parameters. It's a performance specification bid. But there are times when we get in front of the project and would probably enter an engineering services contract if there is extensive engineering. If there isn't extensive, we may just provide, you know, the assistance at, you know, no cost. So it depends on the project, but we would certainly have that capacity to assist.
Okay, and it's like two more questions. Dealing with a sole source here.
Sole source?
Yep. So are you able to see that question right there?
Yeah, I'm looking at questions. Dealing with a sole source. So, I mean, that can be a concern, especially for a public project, right? Sole sourcing. Although there is a new, I don't know if you call it a memo or a statement from the FHWA that does allow for governments to sole source if it makes sense, basically from a cost standpoint or a product type, if it's for the right application. Sole sourcing is essentially it's an allowed thing. I've got a letter and I don't have it in front of me, but I could share that letter if needed. But traditionally, yeah, sole sourcing is not something that municipalities or any government agency is in favor of. But at times it might make sense and it can be allowed. But otherwise, you know, a lot of these bridge systems are not proprietary. There is some proprietary to that one of the precast arches, but for the most part, if you call out a precast arch performance specification or a structural plate performance specification, those are a you know, a competitive environment, and so we're not not going to be dealing with sole sourcing. So.
And then did you touch on that other question listed there as well? How do you handle requests for bids or proposals so that this product can be utilized?
Yeah. Okay, I see two questions there. Let me go back to the other one. To get to sole source, would you respond to requests for proposal first? Yeah, I mean, we would do anything. That would be fine. That's not a problem to do that. How do you handle requests for bids or proposals so that this product can be utilized? So, you know, from a proposal standpoint, you know, we would submit maybe even a set of, like I said, those conceptual drawings to see if that worked. As far as a bidding process, I mean, we go through the traditional bidding process most of the time, and so we take whatever the plans or whatever is shown in the plans, and we'll bid off of that. If there's not enough information in the plans, which does happen, we will send an RFI, try to get enough information that we can bid on that, and anyone else for that matter. If we're competitively bidding, just getting enough information on that structure so that it can be bid within the parameters of what that particular structure type can handle. So anyways, I hope that answers that question, but yeah, it's probably the best answer I can give.
Thanks, Chad. And unless I see any follow-up questions come up in the next few seconds, hopefully we answered all you guys' questions. If we haven't, feel free to get in touch with Chad directly, or any of us within TV Pipe, and we'll be sure to point you in the right direction, make sure you get the answer you need. With that being said, anything else, Kelly or Chad?
No, I think we're good, Kelly.
Yeah,
right.
does anybody else want to unmute and ask Chad a question and have some feedback directly? That's possible at this point if you want to do that.
Well, thank you again, everybody who attended, and for all your questions and input. And be sure to tune in for our next Reline Lives.
Yeah, thank you.
All right. Thanks, guys.
Thanks, everyone.